All good?
I don't know.
Hi, I'm Joanne Parizeau. On behalf of the Goodrich Memorial Library, welcome to tonight's Snapshot event, Turning Stones, Discovering the Life of Water with St. Michael's College professor Declan McCabe. Snapshot is a Vermont Humanities program that hosts a variety of public speakers at different libraries throughout the state to engage people in conversations. We extend our thanks to our partners at the Vermont Humanities, as well as to our generous underwriters who make it possible for us to offer such rich and robust programming. The sponsor of the entire Snapshot season is the Vermont Department of Libraries, the Institute of Museum and Library Services, and the Alma Gibbs Donchen Foundation. Tonight we come from across the state to listen, to learn, and to be inspired. So, welcome all of you. The next Snapshot event is Gather, a young adult book written by Kenneth Cadow, who I believe is a Vermont high school principal. The book is so good. Read it. If you get a chance, read it. And now, it is my pleasure to introduce you to our speaker. Declan McCabe is the aquatic ecologist and professor of biology at St. Michael's College. His job is to clearly communicate fascinating and complex biology to entry-level students. And he has translated that skill into a successful career as an outreach specialist to high school audiences. He's a columnist for Northern Woodlands magazine and a regular contributor to a syndicated natural history series called The Outside Story, and an occasional contributor to Connecticut Woodlands magazine. He lives in South Burlington. Turning Stones, Discovering the Life of Water is his first book, and we do have a copy here at the library. Welcome, all of you. Welcome, Declan.
Thank you for that fabulous intro. I really appreciate the opportunity to come out, and thank you to the Goodrich Memorial Library. It is a beautiful library, and for the folks who are watching on that live stream, you should come and see the building. You know, check out a book, but you should just come and see it. It's just amazing. So thank you for that, and thank you to Vermont Humanities also. Yeah?
Did she show you the fossils?
No, I haven't seen the fossils yet, but I did see the taxidermy. You get some good collections up here. It's impressive. So yeah, so it's a museum/library, I think. Anyway, it's great to be here. So I'll whip through a few slides, and I'm pretty low key. So if anybody has questions as we go, better to ask them on the spot, and we'll stop and talk about whatever you want to talk about. Does that sound reasonable? All right. So I just wonder if this is going to work. We'll see. Yeah, look at that. I have a podcast if you want to put me on the car someday and hear about all kinds of critters. It's called Nature Snippets, and the beetle there is my daughter's artwork. She's off in art school at the moment, so I've got to give Lauren a shout out. So the book is about water, what lives there, how we can conserve water, keep it clean, avoid messing it up. And the art throughout the book is from Adelaide Murphy Tyrrell. So all of those columns that you mentioned, Northern Woodlands and The Outside Story, first of all, if any of you like to write, somebody has to write one of those every week. And, I don't write that many of them. So, if you like to write 800 words on your favorite critter, send it off to The Outside Story. It's all through Northern Woodlands. But Adelaide was very generous and allowed me to put all the art that she'd already done for the essays into the book, which makes it a far better book. So anyway, I'm going to skip this slide. It's a whole bunch of people that have contributed over the years, but it's just put them up there so the names are there, and then we'll figure out what we get through. Sound good? Mm-hmm. Onward. Okay, we'll skip all of that. Obviously not from South Burlington originally, but I came over for the summer and forgot to go home, and here I am. So the motivation for writing something like this is that I wanted to communicate more about the cool bugs that are out there that don't do us any harm. And the common reaction you get is, how do I get rid of it? And if you Google any insect, almost the first thing that comes up is going to be pest control. And most of them are not actually pests. So let's talk about a few of them. My solution to the water strider was say, why don't you get some fishing spiders? And that was not the answer my colleague wanted. And I spend a fair bit of time identifying things for people. And come on in, grab a stool, make yourself at home. We decided to start without you. We took a vote, and here we are. But welcome anyway. And this was one that I found particularly amusing. I've got these little things. They might be beetles, they might be water boatmen, they might be something else. And do I need to get rid of them? And I replied to my sister, and I said, if your brother was an aquatic entomologist, he might answer the question for you. So even my own sister is trying to get rid of bugs out of her pond. So I'm trying to do something like this, but for the bugs. So the trees have plenty of people talking for them, and we should talk more for the trees also. But let's talk about the bugs. And so the way I do that is I write about them. I've been teaching about them for many years, and I started doing this outreach work for Vermont EPSCoR, and part of it was they wanted me to write things for the public, get rid of my jargon, work with editors, and write them in English that everyone would be happy reading. So I assume when I write something that smart people are going to read it, but that they're not entomologists. So I tried to get rid of a lot of the terminology that is not useful or that it's a barrier. And so I write this column, and so, invertebrate bestiary. And eventually, if we get enough of them, it'll be another book. But anyway, these are the things that keep me happy. And so the focus of the book is life in water, and water is strange. Most chemicals, if you were to freeze them, they're going to freeze from the bottom because the solid phase is most dense. So if you ever made candles, when the wax is solidifying, it doesn't solidify across the top, it solidifies from the bottom all the way up. But ice is the exception. Ice floats. And everyone knows the ice floats. Anyone who's ever had a drink with ice in it knows that the ice floats, right? And so there's always water under the ice, and our lakes therefore don't freeze solid. And that's kind of important. The reason that the water expands when it freezes is pretty straightforward. So I got all sorts of tangles here. There we go. So if I pull up one of these, shows you what a water molecule looks like. It's a stubby little boomerang. Okay, you've got the H2, right? The two hydrogens are the white ones, and the oxygen is the red. That's it. And they're zooming around doing three-dimensional tag, and they're separated from each other, but they are breaking contact, making contact, right? And then when they start to freeze, they start to get into more of a formation, and they hold each other at arm's length. And so if you look into an ice molecule from any angle, you can see through it. You've got these gaps where the molecules are separated from each other, and therefore the whole lot expands. And if you've ever put a glass bottle of water in the freezer, you've only done it once, right? And my son, I got a shout out to my son too. We have a car at home that hasn't been used in a while. He left a 6-pack of non-alcoholic beer in the car, and it froze, and luckily it expanded. There was enough room in the aluminum that it didn't actually split. It just bowed out both ends. So the water expands, becomes less dense, and it floats. So it's fun. That's how water freezing works. Anyway, other cool thing about that is the water temperature underneath is constant. It is 4 degrees Celsius, no matter where you happen to be. 39 degrees Fahrenheit if you like Fahrenheit. But any lake that has ice on top, anywhere in the world, that's the water temperature underneath. It's just a physical constant. And so life can evolve to match that water temperature, which is kind of cool. So you get life underneath. And so if you've ever gotten the unfortunate fish at the fair in a little plastic bag, right, and you took it home, if you dumped it straight into the aquarium, it would be a dead fish. And they tell you, float the bag for a while, let the temperature adjust slowly, right? And so you and I all have enzymes that work at human body temperature. And if you get a fever or if you get hypothermia, you're in real trouble because your enzymes don't work anymore because you only have enzymes for that temperature. But anything that lives in the lake can adjust and make different enzymes for different temperatures. And so they make enzymes for 4 degrees, and all of the insect life in the lake is doing just fine right now. And of course, this also makes ice fishing possible, which is important around here, I guess. Any ice fishing this year? Was it a good year for ice fishing? I don't know. I've taken students ice fishing. And this is always entertaining because they are terrified that they're going to go through the ice. And so I'm substantially larger than most of the students. So what I do is I walk out onto the ice and I do a good big jump, and then they come on. So it's a lot of students from Boston and places like that that have never been ice fishing. But anyway, it's fun. We'll skip heat capacity. Let's go on to surface tension. Surface tension. Steel does not float, right? And yet there we have a paper clip sitting on top of the water, and it's because of surface tension, which is an amazing trampoline on top of all of our ponds and lakes, right? And it's a force for good for some things that like to walk on water, and it's a force for bad for other things that fall in and get tangled because they're not adapted to that. So obviously things are not floating. They're especially if they're denser than water. Ducks are floating. If you or I swim, we're floating. And if you take a deep breath, you'll float higher, right? But these things are actually riding on the surface tension. And here's my favorite example. Anyone got arachnophobia? Should we move on fast, or are we all good? Okay, so this is a fishing spider, and they will occasionally eat fish, but mostly they're eating other bugs. This one is the six-spotted fishing spider, and if you count the spots, you'll think, who the heck named it 6 spots? It's got more than 6. The entomologist who named it was looking at the underside. No one gets to see the underside except an entomologist or something that's getting eaten by a fishing spider. So what they mostly eat rather than fish, and this is one of the biggest spiders in Vermont, you will find them, very cool beasties. We did a program at North Branch Nature Center last year for some kids, and we're in and out of the river all day, kids coming and going and families coming and going. And we're supposed to wrap up at 3 o'clock, and about 10 of 3, this family shows up with a little boy who's super excited. And I was like, okay, here's the deal. We're going to do the program. You're going to help me clean up. And they went for it. So I was like, okay, let's do it. So he was very rambunctious, jumping in and out and behaving like a 7-year-old because, he was 7. And he stomped on the riverbank and broke off a piece of riverbank and outshot the fishing spider that we had been stepping over and back over the whole day, and none of us got to see it. He was the only kid who got to see the fishing spider. So the whole bunch of us quickly corralled it with our hands on the water surface so everyone could see it walking on the water. And it was a cool moment. So fishing spiders are wonderful. They're huge. They are quite large, intimidating to some. I have seen 20-year-old men screaming when they find them when we're out doing field work, and they survive. So, but this is mostly what they're eating. They're mostly eating water striders. So this is the most common thing you're likely to see on the water surface. Usually you see the shadow before you see the bug. And this is what the legs look like that are pushing down on the water surface. I'll show you that in a second. But the way they hunt is they've got those long legs, and at the front they've got 2 legs that rest on the water surface that you barely can even see, and they're feeding for vibrations. And those 2 legs have a single spine. It's almost like you had a spike coming out of the palm of your hand. And when they finally do get a bug, they just impale it with those 2 spikes, and it's lunch. And so here's how they stay up on the water. That's what the leg looks like when you zoom in nice and close. And all of those fibers are water repellent. And so it's almost impossible to get them under the water. There's even a species that goes out onto the ocean. It's pretty much the only insect you'd find out on the ocean, like way out, like many miles from shore. And it seems to survive big waves and everything. It just rides along. And I've only been out in a situation where I could catch one of those once or twice, and I always fail to catch them. So one of these days I'm going to find one. But I got to get out more often on the ocean. More commonly, you might see whirligig beetles. So I have to say it slowly, whirligig. So whirligig beetles zip around like little rudderless motorboats on the surface. And they are out there in broad daylight. Nothing seems to eat them. Things that do eat them will only eat one because they taste really unpleasant, and you get a food aversion, and so that distasteful flavor protects the species. But that's not the coolest thing about them, I think. The coolest thing is if you look at them from the side. There's 2 things. First of all, they're dark on top, pale underneath. And that's a really common pattern in nature. So when you look at them from above, they're camouflaged against the pond floor. And when a fish looks at them from below, they're somewhat camouflaged against the sky. So you'll see that in seagulls, you'll see it in fish, you'll see it in military aircraft, contra-shading. But that's not the coolest thing. Look at the eyes. So you can see an eye here, you can see an eye there. and there's two more on the other side. So it's a four-eyed beetle. So two eyes are looking down, two eyes are looking up. And the ones that are looking up are actually attuned to looking through air, and the ones that are looking down are attuned to looking through water. There's different properties of the lens surface. I think it's cool to see a four-eyed beetle. I can't think of another one. So yeah, anyway. And then of course, everyone's favorite thing working with the surface tension, these are mosquito larvae. And so I have a tip for everybody. Let's assume for a moment that you have a pond in your yard, or you've got a bird bath, and maybe you don't want mosquitoes. All you need is a bubbler, or if you want to be super fancy, you can have a fountain. And the disruption of the surface tension will not allow the larvae to breathe. So if you want to get rid of mosquitoes without using chemicals, that's the way to do it. And the little lump that you see on the side of the screen there on the left, your left, I believe, that is an egg raft. So even the eggs have to float, depending on the species. Some of them will lay eggs in a dry pond, and when the pond fills up, the eggs hatch. And then others will make these egg rafts. So yeah, and then of course, when the mosquito comes out, it has to walk on the water to get away. So that's the pupa underneath the water surface, and the mosquito's walking away, looking for you or me. So yeah, the surface tension all the way through their life. The single easiest way to get them away from your house, clean your gutters. Your gutters are just a pond, a nice linear pond the whole length of your house. And if you keep your gutters clean, you'll keep the mosquito populations down. So, and there's another thing you could do with your gutters. My house is, I don't know, probably 90 years old, and the gutters are starting to fall down. And I called the gutter guy, and the gutters used to run down the downpipe to the driveway out to the street. And seemed like a good idea to move the water out, whoever designed it, right? Problem is it causes erosion in the rivers. So the water goes into the rivers really fast. It causes bank erosion, it causes bed erosion. And it was at the corner of the house, which is a convenient place for the downspout. But the gutter guy said, you can put the downspout anywhere. We just have to make sure that the gutters drain to wherever we put the downspout. So now the gutters come down, go through a hole in my deck, out under the deck, onto the lawn. And instead of rushing all that water onto my driveway, it goes onto the lawn. And it can soak into the groundwater, everyone's happy. And I no longer have ice on my driveway. So, win-win. Save the rivers and save myself falling on my rear end when I'm on the driveway. So, okay. Flowing water versus standing water, different things live in different places. And if there's questions as we go, stick your hand up, give me a yell, we'll stop and try and answer. And if I don't know the answer, I'll tell you I don't know the answer. So, flowing water has lots of oxygen, and it is flushing, and it's eroding. So, the rocks in a clean river are clean rocks perched on top of other clean rocks with lots of nooks and crannies in between. And when the water runs fast, the bugs will actually crawl down between those nooks and crannies into the storm cellar. And so when you look into a river and there's churning erosion happening and there's boulders coming down, and there's tree trunks coming down, the bugs are all down in the storm cellar and they're safe. All good so far, unless your stream is heavily impacted and you've had that erosion problem, which leads to deposition, which fills in all the nooks and crannies. And that's like the concrete truck backing up to your house and putting the chute in the window and filling all the rooms. They can no longer get to the storm cellar. So that they call that urban stream syndrome. And if you're involved with kids, or you're involved in stream monitoring or watershed group, one of the things you can do is pull rocks out and look for a bathtub ring. And the more bathtub rings and the more rock that's covered, the more impacted your stream is. And what I mean by a bathtub ring is the rock was stuck in the muck and you had to kind of go to pull it out, right? That's what I mean. If you're in a very healthy stream, like your stream's mostly around here, you're not going to see that. So, yeah, anyway. Okay, so leaf season. Let's talk about leaf season. So the leaves change color and folks get on the bus in Manhattan and they come on up here and there's convoys of cars. A friend of mine comes from Pennsylvania and rides around in a convoy of cars so that she can go with her friends to do leaf peeping. And I'm sure it must drive you crazy when you're trying to get anywhere, right? Welcome to Vermont. The leaves are the base of the food web for any river, okay? Leaves fall in and they're inedible because, you know, a leaf on a tree has all sorts of chemicals to stop bugs from eating it. The tree didn't grow leaves to be a food source. The tree grew leaves to do photosynthesis and be a tree, right? So when they fall off, they're still inedible. So they got to soak for a while like a tea bag and get rid of the nasty chemicals. And then you need bacteria and fungus to grow on the leaf, and then it becomes edible. And that's the process. They call it conditioning. And the shredders come and eat the leaves. So if you've got linden, basswood, it's got soft leaves, very tender leaves. They fall fairly early, and they're food source right away. Maple is a little bit tougher, falls a little bit later. You've got a food source that's coming a little bit later. If you go out in the woods now, you'll still find oak trees that have their leaves on there, and beech, and those leaves are more leathery. And they fall now, or they fall later, or they fall gradually through the season. And what the point I'm trying to make is if you have a diverse forest, you've got a food source for the bugs all through the year. And let's pretend for a moment that you don't like bugs and you're at the wrong talk. The fish like the bugs. Have you ever taken a leaf and put it on a hook and caught a fish? Doesn't work. The fish don't eat the leaves. Got to have the bugs. So if you want to have the fish and you want to have the kingfishers, and if you want to have the bald eagle, right, you got to have the bugs. So to not like the bugs in the river is clearly anti-American, right? You got to love the bugs. All right, so here's some stoneflies. So stoneflies, I'm not going to do a whole entomology lesson, but stoneflies have two tails. You'll get lots of them in your clean rivers around here. They're a really good indicator of clean water quality. If you've got a lot of stoneflies, lots of different species of stoneflies, you've got good water. So, another one, this looks like a disarticulated pinky finger. This is a cranefly larva. So if you've left the windows open at night and left the lights on, the craneflies will fly in. They look like a huge mosquito, and people are not usually fans of them, but many of them start out in rivers. So, some people call them mosquito hawks. They're Topulidae is the family, but all true flies lack legs, so they're maggots, you know. And this is well, they lack legs as larvae is what I'm trying to say, and they've got two wings as adults. Most of the things that might bite you are dipterans. So mosquitoes, horseflies, deer flies, black flies, tsetse flies, almost all the things that bite you are dipterans. So and houseflies are dipterans also. And the ones that I really despise are called stable flies. They look like a perfectly normal housefly until they find the back of your leg and they bite you. I don't know if you've had that experience. If you've been around horses, stable flies are, I really despise them. Anyway, what have we got? Okay, so we had the leaves, and lots of things eat leaves. Now let's talk about particles. So lots and lots of these things are making particles because they're eating the leaves, breaking them up, and they're messy. And organic material washed off a farm, washed off an urban area, washed out because of soil erosion, particles end up in the water. And frass. I got a good book reference for you here. Frass is important, and everything poops, and that might be distasteful to you, but there's bugs that want to eat it. So there we go. And this is everyone's favorite bug. This is a black fly. They look like a little bowling pin, and at the top end they've got these really cool fans. And I was at a conference one time, and you look through the conference menu, you know, and you think there's some, you know, highfalutin titles to many of these presentations. You need to decide which one am I going to attend next. And I saw one that was maggots and murder. And I thought, okay, that's the one for me. And, you know, everyone was trying to get in the door. But Rich Merritt gave the presentation, and he told us how the black flies solved a murder, which I thought was really cool. So I had to write about that. And so what happened was, and to you, what happened was, are we getting questions in the feed? No, I have no idea. Or I don't know, maybe just beeped arbitrarily. What do I know?
Not yet.
Oh, good. Excellent. Well, that's easier. So anyway, this guy, his story was that his wife disappeared. She walked out, they had a little argument, everything's good. Her friends saw her in December, and family saw her in January, and she's going to be coming back, or maybe she won't. We just weren't getting along, you know. And then the scuba divers found her body in April in a car in a river in Michigan. And they scraped things off the windshield and sent them to an entomologist. And he said, no, she's been there since September. because the black fly cases that were put on the windshield of the car can only be made and laid down by that species in September. So the black fly sent them to prison. So yeah, you know, even if you're not a fan of bugs, they have their uses. And every time I'm watching like one of those CSI shows, about every fifth episode there'll be a something with bugs, and I'm listening carefully to see if they got it right. So everyone has their problems, right? So the single most common thing that I find that filters particles are these net spinning caddisflies, and they're really cool looking bugs. If you look on the surface of a rock in the river, you'll see these kind of letter C shaped structures. Water's flowing over the top of the rock, and those are nets. And if you zoom in on those nets, this is what they look like. So they're made out of silk, and the caddisflies have little nozzles on the front end of their face, and they'll swipe their face across and lay down several strands of silk. They'll swipe it the other direction, they've laid down several more strands, and you've got yourself a net. And the distance between the silk strands varies by species. So, but anyway, they're cleaning the water, and most rivers are going to have net spinning caddisflies in there, which is kind of fun. So I didn't have the time to get some live ones today, so I haven't got them for the microscopes, but what can you do? Anyway, really important little bugs. This is one we had on screen a little bit back. This is, so do we remember what this one is? This was the water penny beetle, super flat, and it lives in the fast flowing river without getting washed away, because it is in that boundary layer where there's very, very little, there's so much friction that there's very little water velocity. And they can live even in a fast flowing river with the water flowing over top, because they're not experiencing the high water velocity. And if you flip them over, they've got gills, they're super round on the edge. So that's the true water penny. And this is the false water penny, which has an edge that looks kind of like a saw or a bread knife. Different bug, no gills. And then one other cool way to stay put is to attach a whole bunch of rocks to your body. So these are caddisflies, and they basically live in a silk-lined sleeping bag their entire life, which they haul around with them. And different species put different things on there. This species is Neophylax, puts rocks on there. And the one with its legs sticking out is still a larva walking around. The one next to it with the rock in front of where its face should be is a pupa. And it sits on the rock for the whole summer. And if you can imagine hundreds of these things piled up and all the nooks and crannies they create, other beasties move in between the nooks and crannies. And one thing we discovered at St. Mike's was that when you have these caddisflies on a rock, the diversity goes up about twice. So you get twice as many species. And they also are very camouflaged. And you can prove this by rearing them in something else. So if you rear the caddisflies in semi-precious stones, or fool's gold, or whatever you like, they'll accumulate it into their cases. And then in your spare time, if you Google caddisfly earrings, you can go buy caddisfly earrings. I kid you not. So there's somebody out on Etsy, raises caddisflies in little trays of, semi-precious stones and sells them as earrings. So if you ever needed the gift for the person who's got everything, this is it. I swear I'm not getting commission.
So they live most of their life as a pupa, and then in the fall, the adult will merge,
Yeah.
Mate,
Yeah.
and eggs will be.
Yeah, the female will crawl back into the river, lay a little gelatinous lump of eggs underneath a rock, and the life cycle is complete. Yeah. So the adults, it depends on the species. Some of them are fall. Like the one I just showed you on the previous slide is a fall emerging species. There's some that emerge in May, some in June, and there's even a winter caddisfly. So there's, and they have, all of the insects that do this type of thing have a really tight pattern of emergence. So the hatch comes at a certain time. You've done your whole life cycle. You better be there when the members of the opposite gender are there, or you're out of luck, right? So they have to come in a tight synchrony. And the fly fishing people will tell you exactly what's hatching when. And the hatches move upstream, which is really cool. They're based on water temperature. So if it hatches, in town on a Tuesday, then probably the hatch is going to be upstream on the Monday, and or on a Wednesday, and farther upstream on the Thursday. So it's really a cool thing. Yeah.
Can that fly unblend itself by getting its net off and having the stuff drop off, or is it, once it's on there, it's on there?
Once it's on there, it's on there. And there's one really cool one around here, Pycnopsyche gentilis, starts off making a leaf case. And so the case, it's like a little triangular tent made out of perfectly circular discs of leaf. And it does that all through the fall. And when it gets bigger, it starts putting rocks on the front. And if you find them in January, February, there'll be leaves at the back end and rocks on the front end. And then eventually the leaves all fall off over time and it adds more rocks and it replaces it entirely. So.
That's another question. Does the fly rot out so that people don't have stink coming out of their ear?
Oh, I'm assuming they have removed the caddisfly. Yeah.
Remove it from it. Like,
Yeah, I would think they remove it.
okay.
Not sure it would end well for the caddisfly.
They get it.
Forceps.
Oh, little tiny.
Yeah, I mean, I've for identification purposes, I have pulled them out of their cases. It's difficult. They've got hooks at the back end, and they really hang on tight. So yeah, they've got claws. So yeah, it's fun, isn't it? Anyway, this is my strange obsessions. Somebody has to like the bugs, right? Might as well be me.
That one was like really vogue.
Yeah. And some of them use living algae cells. Some of them use live moss. It's amazing, the diversity, and the cases are useful for identification. There's one that uses sticks, and when I was a kid, this is true nerdism here for you. When I was a 12-year-old, my science fair project, I threw matchsticks into an aquarium of caddisflies, and they put the matchsticks into their cases. So this is what happens when you let your kid get a little bit too nutty with the bugs. Be careful out there. Encourage their strange passions. They got to do what makes them happy. Huh?
You go buggy.
Yeah. My kids are all artists. My wife and I are both scientists, and my one kid just finished her MFA, or is finishing her MFA in nonfiction. The other one's a filmmaker, and my youngest is in art school. So this is what happens when scientists have babies, I guess. So they got to do what makes them happy. Anyway, still water. It's standing water, but it's not still. Standing water, lakes and ponds. But if the wind blows, if you've ever been out in that lake and the wind blows, you'll experience that it's not still water, but it's not flowing. And the example I like to use is Lake Champlain. If you could shut off the rain and all the water sources and allow the lake to continue to drain through the river to the north, it'll take about 3 years to empty the lake at the average flow rate of that river. So that's what I mean by standing water. It's just not as much flow happening. So, everyone kind of knows what a lake is, kind of knows what a pond is, right? So there's more deposition happening. And when the rivers come down with all that energy, carrying all the material, they hit a lake and it gets deposited. Oxygen is more limited, and it's a very different habitat, so different things live there. And you get layers. So let's talk about the layers. I've been to lots and lots of lakes, go for a swim, and frequently there's somebody there who'll tell you, if you go a little farther out, there's springs, and you'll feel the springs on your feet. Have you heard that conversation? I've had the conversation in Loughree in Ireland, Arrowhead Lake in the Poconos, and North Beach near Burlington in Lake Champlain. And some places there are springs, but in every lake there's cold water out farther, just because there's separate defined layers. And if you walk out and you're about this far deep in a lake at the right time of year, your ankles will be cold. Any scuba divers? When they train you for scuba diving, they'll take you to what's called the thermocline. They'll take you out there and they'll bring you down so that the lower half of your body is in cold water and the upper half is in warm water, and you will tell the difference. It's like sharp contrast. And then if they're really good trainers, what they'll do is they'll take you down into the cold water below the thermocline, and they'll make you take off your face mask and put it back on again. So you experience that cold rush of water in your face, and you don't panic, and you put your mask back on, and everyone goes home happy. But it's like very, very stark difference in temperature. So it's an experience, not for everyone. I stopped doing it. Ear infections, what can I tell you? Too much information. So this is what a lake looks like in the summer. It's got the layer cake going on. Light is limited to the upper surface areas and a certain depth, and then it all gets absorbed. And the more algae you have in the lake, the faster that light gets absorbed. And then deeper, it's super, super dark because all the light has been absorbed. The blue light travels farthest in water, which is why if you see a white sand lagoon somewhere, it looks blue, because the blue has traveled down, reflected off the bottom, come back up again. It's kind of cool. Yay, physics, right? Anyway, yeah, that's the layer. So in the fall, at some point, that water that's warm on the surface gets cold enough that it becomes denser than the water underneath. And then gravity has to take its course. That dense water has got to sink. And the water underneath is going to come up. And the whole lake turns over. And that happens. It can happen more than once in a year, but it happens at least once in a typical lake around here. And it's a major upheaval. And oxygen is brought down, and nutrients are brought up. And so if you've been reading the newspapers at all about the state of Lake Champlain and the state of our lakes in Vermont, phosphorus is a big deal, right? And we want to reduce the phosphorus. Problem with lake turnover is the phosphorus that we put on the landscape in the 70s, because we were paid by government grants to do it, is still in the soil, still getting washed into the lake, and is still in the sediment. And so we need to shut off the phosphorus supply. We need to slow that down. But we're doing it for great-grandchildren. We're not doing it for us. It's a long-term process. It's going to be a long time. It's called legacy phosphorus. And that's the most depressing part of my talk, I hope. So, yeah, there's the winter. Ice on top, 4 degrees underneath. We covered that earlier. All right.
Can you go back to the thermocline?
Yeah.
What keeps the thermocline? What about it keeps
The separation?
the separation?
Density. Yeah, so the cold water is high density and the warm water is low density. And there's such a difference in density that you don't get a lot of mixing in between. And here's the coolest part. In Lake Champlain, it's a long lake, right? If you got the wind blowing from the south, it'll push the warm water to the north end of the lake. And because of that, the cold water gets shoved in the other direction. And the thermocline, instead of being flat, goes like this. And then the wind goes away, and it sloshes around, and it keeps going like that. It's like a heartbeat in the lake, and it's like a 2-day periodicity. Imagine if your heart was to beat every 2 days. And it's a huge volume of water. So yeah, the density difference is real. It's, yeah, really cool. Yeah?
We have a question from online.
Yeah.
Asking, what really defines a pond? Because it doesn't seem like the size is the biggest factor.
Yeah, it's confusing, and I've got examples in the book where there's a named pond that's bigger than the named lake that's the next town over. So there's several definitions. One is lack of waves. One is that the thermal mixing is more to do with convection currents rather than the alternatives. So lack of waves is a big one, but one person's pond is another person's lake, so it's kind of. Yeah, it's not easily defined. Depth, some people say there's no thermocline in a pond, so it's not deep enough to have a thermocline. That's another definition. So there's at least 3 competing definitions. Hope that helps, yeah?
So when you were explaining that ice has pockets
Yeah.
of air,
Yeah.
do those pockets also begin before the water freezes? Does the different temperatures of water have bigger and smaller
Yes,
pockets?
absolutely.
So what prevents the warmer water from going into the pockets?
Yeah, well, it's at such a molecular level that it isn't even a pocket of air. It's just it's molecules that have pushed themselves apart a little bit, and so the density of molecules in an area is simply less, but there isn't necessarily air in between. Does that make sense? So
But it definitely, the colder the water gets,
yeah.
it's expanding before it even reaches ice.
So yeah, it contracts. It gets to 4 degrees Celsius, which is still liquid. 47. What did I say the number was in Fahrenheit? 39. Thank you. 39 Fahrenheit. It reaches maximum density, and then it starts to expand, and it's still liquid until it hits that freezing temperature. So
So there's like a small window
there is.
where it's still liquid, where
Yeah.
it begins to expand, but it has to get down to that temperature before the expansion starts.
Correct.
I got it.
Yeah. So you can actually make a thermometer out of water. We've done this with the students, and it works really well as long as you stay away from 39 Fahrenheit. So water thermometers are fine in temperatures you might like to live in? Yeah, it's a good question. It's fun stuff to think about. I had to have a chemist. I had to sit down with a chemist and have a long conversation. She sorted me out. So Christina Chant is one of our chemists over at the college, and she's a physical chemist, so she really has all that stuff down better than me. So underneath the water, underneath the ice, a lot of ecologists assumed there wasn't much happening because, you know, they're academics, they're teaching during the year, and they do all the research in the summer. So there's a shortage of information about what happens in the wintertime. But Jason Stockwell did a really cool project on Shelburne Pond. He's a UVM researcher, and he sent his students out into Shelburne Pond with ice augers and pumps, and they figured out that the things that happen in the lake in the summertime are still happening under the ice, but at a slower rate. And so the zooplankton, these little water fleas, are eating the algae. You can see he's got a green stripe in his body. That's his gut. So you can see he's had a good meal. And one of my favorite beasties, the phantom midge, goes after the water fleas. Okay, I want to tell you the story of the phantom midge. I had to write about them just because I like the name. And I used to see them growing up. They also call them glass worms because they're so translucent. So at the front and back, you see a black structure. You see the eyes at the very front, and then there's a big hump with another structure, and at the back there's another one. Those two structures, other than the eyes, are bubbles. And so I wrote about them, and I said that, you know, they rise and fall. At the daytime, when fish could see them, they're at the bottom of the pond hanging out in the muck. And at nighttime, they come up and eat their water fleas. And then when the sun rises, they go back down again. And, you know, that's kind of what I've been reading about these things for years, and I was able to do find some information, write the essay. And the editor, I love editors, the editor came back and said, well, that's great. You've described what they do. How do they do it? And I've been reading about them for a long time, and I said, well, nobody knows, because that's what all the textbook says, right? She's like, come on, somebody must know. So I went back to Google Scholar, and I looked again, to be polite and do my due diligence. And sure enough, 2 months before I wrote the essay, someone had discovered the mechanism, which just goes to show there's all the bubble, yeah. The bubble contracts and expands, right? But the mechanism was never discovered before about 2 years ago. And it's all about pH.
So cool.
It's amazing. The animal can adjust the pH around the bubble. And I forget at this point whether it's acid or base, but in one of those conditions, it causes proteins in the bubble to contract, and it compresses the bubble, and the thing sinks. And then it just reverses the pH, changes the acidity, and the bubble expands. And it's not a muscle, it's a protein, a contractile protein that had previously been unknown to science. So kind of cool. So I was glad the editor had pushed me to go and figure out what someone had discovered. And the migration is amazing. If they're in Lake Champlain, they could be going 200 feet in a single day, twice a day. They're commuters, up and down, up and down. So anyway, that's phantom midges for you. Not just something with a cool name. So any other questions? Are we happy rocking and rolling? All right. Here's what I'm going to do. I'm going to skip over to sediment because it's not that exciting. We study sediment. It's fun. It's beautiful muck. We get the bugs. Is anyone interested in getting bugs out of water? Is that sure? I'm going to show you one technique. Just one technique. You need the fancy equipment. You got to go to the dollar store and get one of these. And if you fill that up with muck, maybe you're going to take a child out to look for cool bugs, fill it with muck off the bottom of the pond and bounce it up and down on the water surface. Because otherwise, all you have is a whole lot of muck and you can't see the bugs. But just by bouncing it up and down on the water surface, it rearranges the particles, the muck will go through the sieve, and the bugs will get left behind. And you can do that with a $200 sieve bucket like we use for research, or you can go to the dollar store and get one of these. Do it fast though, Dollar General is closing down. That's what I heard yesterday. Anyway, we do a lot of work with students in the lake and other places. That's why I do what I do. Students want research opportunities and we can provide them. So yeah. So some of the things that live in the lake are things like this burrowing mayfly. I want to defeat a little stereotype of mayflies. They're called ephemeroptera, and it's ephemeral, and they always say, well, they live for 2 days. So I'd like to rehabilitate their image a little bit. Before they live for 2 days as adults, they've lived 2 whole years of extended childhood in the lake. So those things you see coming up out of your lake in a big emergence that's enough to actually show up on, Doppler radar sometimes, they have been 2 years in the lake before they came out. And who wouldn't want to have an extended childhood, right? Anyway, I guess, yeah. So those are, we'll skip over. Oh, I want to get to this one story. So if you look at, can you see that on screen, what I'm pointing at? You see the thing moving? No? Okay, I'm going to point at it old-fashioned, old school then. That thing over there, I'm going to walk over. This thing right here, that is an eastern lamp mussel. And you've got them in the streams and in the lakes. And there's a guy named Rich Kelly took this photograph. And what you can see is a kingfisher has caught himself an eastern lamp mussel. And so Rich posted the photograph, and I had a bit of a eureka moment. It never happens, but it did that day. I said, I know exactly what happened. And so I wrote the essay. Adelaide turned it into her beautiful art, because that's what she does. And she credited Rich Kelly for the photograph. Eastern lamp mussels are not something that kingfishers try to eat. If you look at the diet studies, you're never going to find an eastern lamp mussel. But eastern lamp mussels do something very strange when they need to reproduce. They sit like a bump on a rock. They don't move around very far. And so they want to disperse their offspring. So, everyone see the fish? Everyone see the fish? It's not a fish. That's a part of an eastern lamp mussel. So it grows this structure out of its body and waves it in the water. And I've got a video, which is not my video, but you'll see the credit comes up in a second. Check this out. So this is how they fish. They put that structure out there. Different species grow different structures. Some of them have fins, some of them have eye spots. And when the reproduction season is over, it just gets absorbed back into their body. And they grow new one the following year. And the goal is, there's the credit for that video. He gave me permission to use it. They want to attract a fish. And if it's eastern lamp mussel, they have to attract a yellow perch. And the yellow perch will strike at that fish to try and eat it. And it will fail. And at the same moment, the eastern lamp mussel will release all of its offspring. And they will clamp onto the gills of the perch. The perch will swim away. And in the fullness of time, when the mood strikes them, they'll drop off in a new habitat. And so my theory is that kingfisher, if that thing is good enough to fool a yellow perch, I think it's good enough to fool a kingfisher. And then the way I finished the essay is, I said, I'm going to ask the question, I'm going to interview the kingfisher and ask the question that every teenager dreads, what were you thinking? So these are the strange things I do in my spare time. But I thought it was a cool photograph. And it's, if you're interested in writing, you never know where the inspiration is going to come from. Maybe it comes from a photograph posted on Facebook one night in the Vermont Bird Group. So anyway, I presented this at a meeting one time at a conference, and Chris Maynard was there. He's an artist. He takes a single feather. He somehow treats it on the backside so it doesn't fall apart, and he laser cuts. You probably have the books in the library. Or maybe you don't. It might be worth getting. But he laser cuts out his art, and he took my essay and turned it into a piece of art. I was thrilled. So yeah, that's stolen from his website. He stole my essay. I stole his art. It's all fair. It's not like I'm selling them. So anyway, let's see how we are for time here. It's 7:50. 7:50. Yeah, this is Wendell Berry. I think that's I put that in all of my emails. That's the quote that I send out. Everyone lives upstream. Everyone lives downstream, right? And our landscape influences the water quality, and we can do that for good or for bad. There's things we can do to improve always. I love a good buffer strip. You live near a drainage ditch or a river or a stream, plant a bit of vegetation to protect the water quality. So we're all upstream, we're all downstream, and the bugs are the canaries in the coal mine. I have to explain this to my students. You're familiar with the analogy, but I did find a cool picture actually of a canary cage with an oxygen tank. So they could revive the canary, bring it back as they were coming back up. I thought that touched my heart. Anyway, the bugs are canaries in the coal mine. So when I go out and do a study, there's one of my students out there doing what we do. You go into a river, you kick around, you fill your net with bugs. There's a specific technique for doing that, and you can compare to river to river to river. And the ones that have, cleaner water have more bugs. So if you have all of these things in your stream, it's probably a clean stream. So the stoneflies are on your left, got some dragonflies on the top in the middle there, and there's a water penny on there as well, right? And that's a cranefly in the bottom middle. If you've got all these things, and the more species, the better. Caddisflies, everyone loves a good caddisfly. There's a different one. Unhealthy streams are dominated by a different caddisfly. This is a net spinning caddisfly that's getting all those particles. Midges are in every stream, but if you're dominating, it's not so good. Worms, if your stream is dominated by worms, it's a bad sign. And then these red ones are called bloodworms. It's a confusing name because there are bloodworms in the ocean as well that people use for fishing. They're a different thing entirely. Those are polychaete worms. These are actually a chironomid larva that is able to pull oxygen out of the water with hemoglobin. That's why it's red. So if your stream is dominated by these species, it's an unhealthy stream. And I'm going to show you one data slide. This was Janelle Roberge before she graduated. Now she actually works at St. Mike's. But essentially, on the left-hand side, you have your most forested streams. And on the right-hand side, you've got your streams that are dominated by either agriculture or urban. So does that make sense? Lots of trees on the left, few trees on the right. And what we have is a measure of diversity on the vertical axis. It's 3 groups of bugs, E, P, and T. Mayflies is the Ephemeroptera, stoneflies is Plecoptera, T is Trichoptera. So it's the number of species in those 3 groups. The more trees you have, the healthier your stream. So there's my data slide for today. So, lots of bugs. Let's see, it is 7 minutes before 8. Any questions? I can show you more slides. I can answer questions. Whatever makes you happy. More slides? All right. Fair enough. All right. Most insects have a life cycle like this. They come out at some point. And then there's a bunch of things like isopods, amphipods, crayfish, snails that never come out of the water. So it's a very contrasting life cycle. It's got an emergence phase or it doesn't. So lots of things come out. And the things that come out that get my attention are the things that people bring me in, Chinese food containers, and they're convinced that they're going to consume their children or something. So that thing on that person's hand over there is a Dobson fly, and that's a male. And those sickles at the front end are its mandibles, and they can't bite. They really can't bite you. They use those, if they encounter a female and there's another male, they'll slide up to the male and they'll flip those mandibles underneath the male, and they'll just flick their head and they'll scoot him off into the vegetation, and they have gotten rid of him. So now they have the undivided attention of the female. The one belly up on the other side is the larva. It's a helgramite that becomes that Dobson fly. And if you mishandle them, they will bite you. And the adults, the females have short mandibles that are functional. So if you mishandle an adult female, she'll bite you. The male is kind of defenseless with those ridiculous big mandibles. It can't do much. But they're the biggest thing that come out of the water around here. And those are the ones that crash into the lights at St. Mike's because we're right across the street from the Winooski River. Those are the female's mandibles. She will get your attention. And there's Adelaide's version. A lot of things come out at such high density that they show up on regional Doppler radar, which is kind of cool. The density of bugs coming out of our lakes is lower than it used to be by a long shot. Insects in general are down in terms of their numbers, and birds as a result are also down in terms of their numbers. So we need to do a better job. Lake Erie has come back from having essentially no mayflies to now having mayflies again. It can be done, and we need to work hard. And I don't want to give you ever hopeless messages. I'd like you to think about a few things. The ozone layer. We all stressed out about the ozone layer. We had the Montreal Protocol. We did something about it. We banned the chemicals, and you don't hear about the ozone hole anymore, right? It's healing. It's not fixed all the way, but it's getting there. Acid rain was a big issue. You don't hear about that as much anymore, right? Because again, we had a lawsuit of the northeastern states against the midwestern states to rectify and put scrubbers on the power plants. And, the Clean Air Act was enforced, and we have reduced acid rain. The bald eagle was nearly gone, right, in the lower 48. And Silent Spring was written, DDT was banned. Richard Nixon, whether you like him or not, brought in the EPA, Clean Water Act, Clean Air Act, right? All of the things that are currently under threat were brought in, and we have made a difference, and it's possible to make a difference. But we have to keep working, and we have to fight the fights that are worth fighting. So, anyway, let's see. Invasives, I've got 3 minutes. Yeah.
We have another question online asking if there's a reason for the whirlybug swimming patterns.
Yeah, it confuses predators, and I've tried to get them with a net, and so they're whipping around, and if I come in with my net, which would be comparable to a predator coming, I guess, they'll dive. It's like an old submarine movie, dive, and they just disappear from the surface. And if something comes from below, they'll scatter. So yeah, it's like the white-tailed deer. The white-tailed deer doesn't flash its tail to advertise to its friends, to keep its friends safe. The white-tailed deer wants them all moving at the same time so that the predator doesn't get them. And it's the same thing with these things. They call it predator dilution. There's more of them in one place, and there's less likely that the predator will get any one of them. So it's a selfish thing. So yeah, same logic as the white-tailed deer. So yeah, kind of fun. So maybe we won't do invasives. There's invasives. So yeah, I think we'll leave it there. It's right around 8 o'clock, and I promised about an hour, and I don't want to make people feel obliged to stay longer than they should. If you do want to stay longer, I've got microscopes down the back, and a few bugs I pulled out of the lake yesterday, and you can have a look. So thank you all. Oh, if you desperately want a book, I'm not doing a hard sales pitch, but if you desperately want a book, I'll sell you one.
So, microscopes are in the back, there's coffee and cookies in the Vermont room. So please hang out.
Thank you.
Thank you all for coming.
Thanks, everyone. I appreciate it.
Is that the crayfish?
Yes,
We got eagle.
we do.
Crayfish.
This is the rusted crayfish.
Rusty.
Yeah.